Now friends, we see the next question. The next question is integral e to the power minus x squared dx from 0 to infinity, and we have to prove that this integral is equal to 1/2 root pi. So we take LHS. So what is our LHS? Is equals to integral 0 to infinity e to the power minus x squared dx. So what we do here is we put x square equal to t. We put x square equal to t. On differentiating we get 2x. Now here we see we have come up till, then we put x square equal to t. Okay, we put x square equal to t, then 2x into dx equal to dt. On differentiating we get 2x into dx equal to dt. Therefore dt dx equal to dt divided by 2 root t, as x square equal to t, therefore x equal to root t. So putting this values an integral, also the limit when x equal to 0, t is equal to 0. When x equal to infinity, t is also equal to infinity, because square of infinity is also infinity. So therefore putting all these things in this limit, we get integral e to the power minus t into dx is dt divided by 2 root t. Therefore dt divided by 2 root t, and the limit remains same, 0 to infinity. Therefore is equals to 1 upon 2 integral 0 to infinity. Here is root 2 is in denominator, so we take in numerator. So its power becomes t raised to minus 1 by 2 e raised to minus t into dt. So we have known now this form. This form is in the form of x raised to n minus 1 e raised to minus x into dx. So x raised to n minus 1 e raised to minus x into dx from 0 to infinity is nothing but what? Is nothing but gamma n. So here it is n minus 1. So minus 1 by 2 is n minus 1. Therefore we take gamma n, that is we have to add plus 1, that is minus 1 by 2 plus 1. What it is? 1 by 2. So gamma 1 by 2 is our answer. And gamma 1 by 2 is nothing but root pi. And how it is, I will tell this in next videos. I will explain this in upcoming videos. So for sake, here we have to consider that gamma 1 by 2 is root pi. Therefore our answer is 1 by 2 into root pi. Hence proved. What we have to prove? This integral equal to 1 by 2 root pi. And this is equals to RHS. Now friends, our next question is integral root x into e raised to minus 3 root x into dx from 0 to infinity, and we have to prove that this integral is equal to 4 divided by 27. So what we have to take this integral as our LHS. Therefore we take LHS is equals to integral root x into e raised to minus 3 root x into dx from 0 to infinity. Now what we have to put equal to, which variable we have to put equal to t. Now how do we understand that we have to put this x equal to t, or root x equal to t, or 3 root x equal to t? So whenever this case comes in the problem, then whatever that comes in e to the power, then we have to put that power equal to one variable, that is here it is 3 root x. Therefore we put 3 root x equal to t. Another problem, it may come e raised to minus x square, as we seen before. Then we have put x square equal to t. Sometimes it will come with some certain constant, that is k square x square. Then we have to put k square x square equal to t. We will see in next question. But here we have to put 3 root x equal to t. Therefore 3 root x equal to t. We put 3 root x equal to t. Therefore on squaring we get 9x equal to t square. On differentiating we get 9 into dx equal to 2t into dt. That is nothing but dx equal to 2 by 9 t into dt. this is dx, and here also root x equal to t by 3. Now here also we see that when x is equal to 0, t is also equal to 0. When x is infinity, t is also infinity. So there is no change in the limits. So putting all these things in the integral, we get integral 0 to infinity, limits are same. Root x is nothing but t by 3 into e to the power minus, now 3 root x is t into dx is 2 by 9 t into dt. So we get final our answer as 2 divided by 9 3 is 27 integral 0 to infinity t square e raised to minus t into dt. So this, now again this formula has come, t square into e raised to minus t into dt. So I had told that this t to the power is similar to integral 0 to infinity x to the power n minus 1 e raised to minus x into dx. So this is similar to this formula, as here it is n minus 1, so its answer is gamma n. So here it is 2, therefore in gamma we get 2 by 27 into gamma 3. N minus 1 it is, therefore we have to take n, that is 3 minus 1 is 2, therefore we have taken here 3. So gamma 3 is nothing but 2 by 27 into 2 factorial. As we have discussed earlier in the from the definition that gamma, that is gamma n is equals to n minus 1 factorial. This is the formula that we have discussed in our first video. Therefore gamma n is equal to n minus 1 factorial. Therefore 2 factorial is nothing but 2 into 1, that is 4 divided by 27, and hence is equals to RHS. Hence proved. So friends, this is our next question. So this question is very important, as you can understand everything from this question. So here integral x to the power n e raised to minus k square x square into dx from 0 to infinity, we have to prove that this is equal to 1 upon 2 into k raised to n plus 1 into root of n plus 1 by 2. So we take first LHS is equals to 0 to infinity integral x to the power n e to the power minus k square x square into dx. As I have told earlier that we have to put e to the power k square x square, therefore here k square x square equal to t. Therefore we put k square x square equal to t, that is on differentiating we get k square into 2x dx is equal to dt. Therefore dx is equal to dt divided by 2x k square. Here only, from here also we can know that what is x value of x. Value of x is nothing but x is equals to root t by k. Okay, so x is nothing but root t by k. After substituting this value here, we get 2 into root t by k. So therefore 1k and here k will get cancelled. So we will get dt divided by 2 root t into k. Okay, dx is equal to dt divided by 2 root t into k, and x is equal to root t by k. Now here also limit won't change, as when x equal to 0, t is equals to 0, and when x equals to infinity, t is also equals to infinity. So putting all these things in integral, once again we get integral 0 to infinity x to the power n. So we have x is equal to root t by k, therefore root t by k whole to the power n e to the power minus k square x square is minus t, k square x square is equal to t, therefore e raised to minus t, and dx is nothing but dt divided by 2 root t into k. So therefore taking 1 by 2 outside, 0 to infinity, so for here root t raised to n and here root t, therefore as we take this in numerator we get root t raised to n minus 1, and here k, and here is also k raised to n, therefore k to the power n plus 1 into e raised to minus t into dt. Therefore, we take this k also outside. Therefore, 1 into 2k raised to n plus 1 integral 0 to infinity root t raised to n minus 1 e raised to minus t into dt. So, we get 1 upon 2k raised to n plus 1 integral 0 to infinity root t raised to n minus 1 e raised to minus t into dt. So that is nothing but 1 upon 2 into k raised to n plus 1 0 to infinity t raised to n minus 1 divided by 2 e raised to minus t into dt. So here once again we will take this as similar to that formula. Which formula? Integral 0 to infinity x to the power n minus 1 dx is e raised to minus x into dx is nothing but gamma n. So it's n minus 1. We have to add plus 1. So what do we get? 1 upon 2 k raised to n plus 1 into gamma. This is n minus 1. So we have to add plus 1. That is n minus 1 divided by 2 plus 1. What do we get? 1 upon 2 k raised to n plus 1 into gamma. So it is nothing but n plus 1 divided by 2, which is nothing but RHS. Hence, these are the some few numericals and problems over it. On the next and upcoming videos, we will talk about beta function, its problem, formulas and numericals over it. Also the relation between gamma and beta function. So up till now, thank you. Thank you for watching.